Welcome to Climate News Weekly. We're here with hosts Darren Howe and Julio Friedmann. Hi, guys.
Always a pleasure.
Good to be back.
Quite a few stories to run through this week. We'll start with the weather and Hurricane Beryl pummeling Texas. So this has led to a massive power outage in Texas with about 2 million people without power for several days. Julio, Darren, what do you guys make from this story? What can we learn from this?
So first, let's talk about the reality on the ground. Yes, it's hit Houston and it's terrible. Before that, it hit Jamaica and was terrible. Before that, it hit Grenada and was terrible. Like, we are expecting these storms. This was predicted by climate models that there would be a higher likelihood of magnitude 4 and 5 hurricanes, and we're seeing it. In the case of Houston, we are seeing insult and injury combined. 2 million people pretty much without power when it was 90 degrees with 70 or 80% humidity, truly awful weather. That has led to a health crisis as well, where there are some deaths attributed to the hurricane. I will say that the state response has not been great. Governor Abbott was at a trade mission overseas. Not a good look. The state took a long time to request emergency aid from the White House. And the president did give a declaration that it's a national emergency, but they took their time on filing that. And CenterPoint is not doing a great job.
And that's CenterPoint, the Houston energy provider.
As of now, it's still about 1 million people without power. And they're saying that next week, maybe 500,000 people still without power. Given the heat and the flooding and all these other things, that's really awful. The only other thing to say about it is we knew this was coming this week. We knew this was coming this month. We knew this was coming this year. And we've known this sort of thing is coming for a decade. So we're going to have more of these stories going forward.
What's the main reason that it takes so long for power to get back on its feet after a situation like this in the Houston region? What would you say are the primary factors responsible?
There's actually a lot of damage. In the case of Houston, there were downed trees that took down power lines and interconnections. Like, someone has to roll out a truck and connect up. I have friends in Houston that lost power for 5 days because their tree fell over on a power line in their neighbor's house. And there's been a lot of that. When you have Category 5 hurricanes, you lose a lot of trees. And there is no fixing that. There are ways to harden it. Over the long haul, you can put transmission lines underground, but that is very expensive. It's not a little expensive. It's really expensive to do that. So as always, there's trade-offs.
So along the same lines, so the world is in line for the hottest year on record as we have breached the 1.5 degrees Celsius limit for 12 months in a row. This particular story is in the Financial Times, and the FT has a great little animation showing monthly global surface temperatures since 1940. This is best, I think, communicated through a visual, because it is just so striking to see where temperatures were, even as recently as the 1940s and 50s, not only how they're increasing, but how they appear to be increasing at an accelerated rate. So the warming is not sort of linear, but you can literally see the jumps in the lines are growing larger on average year over year. It's quite alarming to look at projections for how this is likely to increase even further. I think it's really almost impossible for us to comprehend what we're facing. That's my impression, at least. How do you guys metabolize this news?
I'm calling from Seattle, where I'm here for the Bloomberg Green Conference. I saw a talk yesterday by the climate scientist Johan Rockström, and he pointed out this exact data. And what is alarming is that we can't explain the jump in atmospheric temperature or ocean temperatures or ice failure. Like, we can't predict these. We can't understand them. El Nino plays a role, but it's only a partial role. It can't fully explain the dramatic jump we're seeing. That part of it is as alarming as anything else. It's not just the jump and the trends and stuff like that. Like, we are off the map.
Right. There are a number of climate models that researchers run. These are very computationally intensive models. They're quite expensive to run because of all of the computation time. When you run them, you have to really make sure that you've asked the right questions and you're running them with the right parameters, and that, you've designed these experiments thoughtfully. And you also have to be thoughtful about what these models don't include in terms of inputs or in terms of dynamics that they reflect. And one of the things that is very difficult and so is sort of avoided in a lot of these models are tipping points in terms of climate response. And we think about permafrost, these accelerated processes that are sort of unstoppable. Once you start releasing pent up CO2 and methane in the permafrost, there is no way to reverse that, and it just gets worse and worse. And so one of the questions is, have we started to breach some of these tipping points, and is that what is driving this accelerated warming that's sort of a level beyond what we have expected to see? Julio, I'm out on a bit of a limb here, so I'm wondering if maybe you can flesh that out.
Yeah, fundamentally, we don't know. We don't know if we've breached tipping points. I will say that there has been a lot of work on this topic. And today, the climate and geophysical community has identified 16 specific climate systems which would result in a tipping point kind of failure. The Amazon rainforest going from a sink to a source.
A sink of CO2 to a source of CO2 emissions, just to clarify.
Correct. Thank you. Things like the East Antarctic ice shelf, the slowdown of the thermal systems in the ocean associated with the deep temperature circulation. So there are these tipping points. And again, there has been some work to suggest that we are very close to those tipping points. In a couple of cases, the Amazon is the most obvious example. The Greenland ice sheet is another possible one. But we don't really know. But the fact that we found them, that we think we're close, that we seem to be getting signals off the map should really alarm everybody. There's no good news here.
Yeah.
And we have traditionally and consistently underestimated climate impacts.
Right. Yeah. So I was at a conference this week at Cornell University. It was a meeting called GeoMIP, which stands for Geoengineering Model Intercomparison Project. Essentially, what happens at this meeting is that researchers in the field of sunlight reflection methods, or solar geoengineering, or some refer to it as solar radiation management, are studying various ways in which we might reflect sunlight and essentially reduce the amount of energy that hits the earth and warms the earth. So a variety of methods are proposed. Perhaps the most promising and certainly the most studied is stratospheric aerosol injection, which refers to the injection of some material into the upper atmosphere. A variety of different materials are being modeled and have been studied in different ways over the decades to understand kind of how it might work. I was very surprised at what these models can help us to understand in terms of potential effects on climate, precipitation. Some of the researchers are looking at kind of how do we optimize for least damage from a GDP standpoint, and where we inject this material into the atmosphere in terms of degrees latitude impact damages in the global south versus the global north. There's a large amount of work being done by researchers to try to figure out, is there a way that we can avoid the worst of the warming that we're obviously facing, and perhaps provide a bridge to a future in which we've figured out how to remove enough CO2 and reduced our emissions. Clearly, we're not doing enough given the impacts that we're feeling today. Julio, did you want to jump in?
Yeah, so first of all, the GeoMIP project that you've described is modeled after the CMIP project, the Climate Model Intercomparison, which the IPCC has done for many, many years. That is a critical benchmarking tool for climate modeling. And so there's a methodology in place. I'm glad that the geoengineering community is beginning to use that same rubric. I'm also glad that people are starting to look at this. We should probably do a separate discussion of geoengineering and all of its challenges and warts, whether it's governance or science and equity and all these other sorts of things. But fundamentally, ignorance is a bad strategy.
Yeah.
And studying things is where you should start. All responsible actors in geoengineering today are calling just for study right now. Let's learn more
Right.
that we avoid bad outcomes. And this is a really good first step. I would add that EDF, Environmental Defense Fund, has taken that exact position. We should begin careful, judicious research so that we can understand the options should we need to use them.
Yeah, that announcement happened, I think, about a week or 2 weeks ago. I think that they've received funding and they're standing up a program to do just that. So there's definitely some interesting movement in this space. Let's shift gears a little bit to some news about the EV market. And I wonder if, Darren, you could tell us what's happening in terms of Tesla's market share and what we should infer from that.
Yeah, certainly. Well, this past week, the New York Times reported that Tesla dipped to less than 50% of the electric vehicle market. Now, this is not necessarily a big surprise. People have seen this coming. For many years, Tesla had the market only to itself, and it had extremely high levels of market penetration, 70% plus. But unsurprisingly, as more OEMs and startups have gone into the space and released vehicles that are pretty competitive, that margin has been eroding. In the US, overall electric vehicle sales have been climbing steadily, 11% from a year earlier. This is still less than the 40% year over year growth that we saw earlier, several years ago. Now, what's interesting to note is not every manufacturer has been able to eat into Tesla's market share. It really, surprise, depends on the quality of your product and how good it is. We've seen manufacturers like Hyundai, Kia, they've done really, really well because they found this really sweet spot of value and performance and technology. BMW has also done very well on their electric vehicle sales. Those that have suffered include Volkswagen, Audi. Porsche has been pretty popular, but they have a new model release coming out, so their current sales have declined quite a bit. So, big picture, we don't want to read too much into this and make a mountain out of a molehill. This is positive progress. The more OEMs get into the space, the better. There is one thing that's slightly related to this, which is the impact of declining battery cell prices. So, Bloomberg reported this past week that the price for LFP, lithium iron phosphate battery cells in China have dropped 50% year over year. They're now an average of just over $50 per kilowatt hour. For comparison, last year, those batteries cost almost $100 per kilowatt hour. So, why is this happening? Well, there's a few reasons. Number one, the mineral shortage that we were all worried about in 2021, early 2022, has largely abated. The prices of these raw materials have dropped precipitously.
Why is that, Darren? Why has the mineral shortage concern gone away?
Yeah, a combination of two things, right? I think it's always supply and demand. On the one hand, people were investing in projects assuming that the 40% year over year growth would continue. And now that this dropped to 11%, there's just not as much offtake demand for this. And then on the supply front, humans are ingenious. So I think you don't want to bet against us trying to solve our problems. That's reason number one, raw materials prices. The second one is that China has overcapacity. They've built so many battery plants, largely guided by government incentives. They can't find enough demand in their home market, so they're trying to export that abroad. Now, that's one of the big reasons why we have tariffs and trade issues in the US and the EU vis-a-vis China.
Mm-hmm.
And this is a touchy subject. We've talked about this in the past. My personal take is that, sure, we certainly don't want to be subsidizing China's domestic market and manufacturing capacity, but maybe it makes sense to leverage their expertise to build domestic plants here in the US and in the EU. Another thing just to keep an eye out for is that with these battery cell prices decreasing, it could open up better adoption in other sectors. Heavy duty electric vehicles, trucks. This sector has been through this huge trough of disillusionment. Battery trucks are extremely expensive. The industry has really not moved as quickly as it could be. And this is one of the biggest contributors to greenhouse gas emissions, just because how many miles a truck travels every day compared to your passenger vehicle. Hopefully, with these decreasing cell prices, it reduces the upfront costs of these BEV trucks, and we can have a bigger impact there.
One detail in this New York Times article about Tesla's market share decline is that there are now over 100 electric models that are available in the United States for consumers. I didn't really have a sense of that. That's a lot of choice.
Yeah, I can't reconcile that with myself either. To me, I feel like, maybe there's a dozen, maybe 2 dozen models, but that's pretty remarkable.
Yeah.
The one thing I'll add to this is, as Darren pointed out, they have a less than 50% share, but still a growing global market. A smaller piece of a bigger pie is not a bad thing. We should point out, though, that Tesla also announced they're going to delay robotaxi another couple of months. So there's other challenges the company faces.
Absolutely.
In the CO2 removal market, there was a very large deal that has been done between Microsoft and 1.5 or Oxy. Julio, as chief carbon wrangler in your real job, you probably know a little bit about this. Maybe you could give us an update on what this deal represents or what you make of it.
This represents the maturation of these projects in the market. It's a big step forward. It's a lot of money, 500,000 tons.
How much is it?
We don't know the actual price, but it's got to be well above $1 billion, could be cinching in on $2 billion. It's a big purchase. It is the largest ever direct air capture purchase by a lot. It would represent the output of that plant for 1 year. There are other buyers, but this is a multi-year deal and a large volume. Importantly, In their terms, Microsoft said that they are just doing saline formation storage. There is no associated oil or gas production from this by contract. The market is valuing the CO2 removal higher than the oil production. And that is an important signal both to send and receive. So was very big news here in Seattle at the conference. Unsurprisingly, Microsoft Chief Sustainability Officer Melanie Nakagawa talked about this a lot on the stages here, and it's a very, very big deal. It is also far, far away from the volumes we actually need. In order to hit our 2030 climate targets, we need well over 1.6 billion tons of removal a year, and we are not on that trajectory yet.
Right. Yeah. So to this story, Microsoft aims to be carbon negative by 2030, but its emissions last year, 2023, were 30% higher than they were in 2020. In part, according to their report, this has been due to energy intensive AI data centers. The president of Microsoft, Brad Smith, recently said that if Microsoft is shooting for the moon on decarbonization, the moon is, quote, more than 5 times as far away as it was in 2020. So this is a difficult target that is growing more difficult to achieve as companies like Microsoft and others use more and more power. Anyway, good step in the right direction, but the target is also moving. Any comment on that?
Yes, and this is not the electricity use in the case of Microsoft, it's the actual building of data centers. The amount of electricity that AI and data centers use today is less than charging of cell phones by a lot. People think about this as some enormous thing. It's just the first thing. And the easiest thing, when we compare this to something like building heat pumps and running them, that will be about 50 times more than what the data centers are using. When we talk about things like running steel plants on electricity, that will be many multiples beyond that. So all of this is going to be hard. And the reason why it's gotten so much attention is in part because it is the canary in the coal mine. It's telling us how hard electrify everything is going to really be.
Yeah. So along those lines of electrification, there is a time story on the Zambia copper deposit that Cobalt Metals is exploiting with their partners. Cobalt Metals was founded by Kurt House, who has been on this podcast before, both to tell us all about Cobalt and to participate in one of our debates that we've held. Darren, do you want to jump in on this story?
Yeah, I'm glad you've had Kurt on the podcast before because he probably has a better explanation of his company, but I think it's helpful for our audience to describe what exactly Cobalt does. Essentially, it's a modeling and AI company that tries to reduce the cost of exploring for new minerals. Now, how do they do that? Historically, the way mining companies have worked is they identify an area that's likely to have some deposit of interest, and then they do exploration. But the methodology might be a little rudimentary. So they would drill holes, maybe in regular sections or semi-random areas, to try to find that mother lode that is of interest. The problem is every time you drill a hole, it costs a lot of money. You send a lot of equipment there, there's labor, hundreds of thousands of dollars per drill hole. What Cobalt's trying to do is to reduce that cost of exploration. And the way they do it is instead of trying to just find that mother lode, they say, we should really be trying to reduce uncertainty in the model. So what they do is they run multiple models in parallel to say, based on the information we know, here's what the underground structure might look like. And where they have the highest variance in prediction, they say, let's drill there so we can at least reduce our uncertainty. So they're not trying to find the mother lode on the first or second drill, but overall, reducing uncertainty more quickly, they can find the deposits more easily. They found a deposit that could have 300,000 tons per year of copper production, which translates to billions of dollars a year. And I think this is just more evidence in favor of what I said before, which is humans are smart. Like we'll apply new technologies to solve some of our minerals and manufacturing issues. And given how important copper is to the energy transition, we should be trying to fund more efforts like this.
Yeah. One important thing to keep in mind regarding copper mines, it takes about 10 years to get into production. The International Energy Forum, and I'm quoting from the Times article, recently estimated that the world will need between 35 and 194 large new mines for copper alone, and there are other metals we need as well, through 2050 to support the energy transition. So this is between 1 and 6 new copper mines every year, the size of the one Cobalt plans to dig in Zambia, which is the largest deposit that has been prospected in many, many years.
Well, I mean, going off of what you said, James, this is just step one. Understanding what a deposit is and what the available resources are is just the beginning. And it takes a lot of time and energy and regulations and permitting to get through. So even though this is really promising, we shouldn't discount how difficult it is to do everything else. And we need more innovations throughout the mining space. I was recently at a Mineral X conference at Stanford where Cobalt was presenting. And one of the audience members was saying, I was the last geology graduate or mining engineer graduate from this school back in like the 60s. So mining for decades has just not been a sexy area. It's been an area that's been seen as old, backwards, polluting, not something that young people would want to get into. But given how important it is to our society, the energy transition, AI, and just the goods that we consume day to day, it needs to become an interesting area again.
Yeah, clearly we're going to need more copper in there. And I would point our listeners who are curious about cobalt and what they're up to listen to our episode with Kurt House, where he dives into the formation story and what they're doing exactly and how they work with their partners and other things. So in another story, BP, British Petroleum, expects oil demand to peak next year and wind and solar capacity to grow rapidly in both scenarios that it publishes in its annual energy outlook. This is a study of the evolution of the global energy system out to 2050. This came out on Wednesday. In their modeling, they see oil demand peaking by around 2025 in both scenarios, and then falling as its use in road transport declines. Julio, what's your take?
So BP is no longer doing their BP outlook, but the same study came out this year. They are projecting oil demand to peak in 2025. And that's across multiple scenarios. I think the reporting around this has been overblown a bit, but it's a major projection. And if it proves true, it will be the first time in human history that's ever happened. I don't want to understate the importance of that. People should understand, though, that in point of fact, natural gas demand, they're projecting to rise for another 15 years. Even though you take the wins where you get them, we're by no means out of the woods. In that context, there's this other story about the fact that people are predicting that this winter European coal use will grow. Last year we saw that. The year before we saw that. People called them one-offs. Maybe not a one-off. Maybe we're seeing quite regularly as gas prices become expensive, people will fire up the coal plants. So, as is often the case, multiple things can be true. We are having record deployments of renewables. We're spending more money than ever before on clean energy. We are making incredible progress. Looks like coal and gas will continue to rise. Looks like oil may peak next year, but we'll have a slow decline. We just simply are going to have to do a whole lot more to get to where we need to go.
And that's where we'll wrap up today on Climate News Weekly. Thank you so much, Julio. Thanks, Darren. See you next time.